Good evening and welcome you all for the ninth and the last session of Science Talk organized by Science Association in Today's talk is organized in collaboration with Department of Mathematics, Sir Parshuram Bhau College, Pune. Today with us our active and former principal Professor Vinayak Solapurkar. We have Dr. Gitanjali Pathak, active colleague. We also have Amar Pote, active member of Science Association, and the eminent speaker of today's talk, Dr. Abhijit Ranjekar, is with us. I welcome you all. Ranjekar sir will speak on the mathematics in nature, and I would like to request Professor Vinayak Solapurkar to give the introduction of Department of Mathematics in brief. Please, sir.
Okay. Hello, everyone. Dr. Kakade is in charge of Science Association of SP College. All my colleagues, Gitanjali Madam, Amar, then today's special guest or speaker, and my student, Abhijit Ranzekar. I feel that one student should not be forever called student. Now he is at par, if not more. He has acquired a lot of reputation, and he is a colleague now, not a student. And just to tell briefly about the Department of Mathematics, SP College, it has long and glorious tradition, and few departments that started with the college in 1916. Department of Mathematics started in 1916 and already therefore crossed 100 years. And in these 100 years, department developed in various directions. And stalwarts have given their services in the Department of Mathematics, which includes people like Wrangler Kerker, Professor Railkar, and many other great teachers. And the present faculty is trying to keep that momentum going and keep the activities running the Department of Mathematics. In last some years, department extended the training from undergraduate to postgraduate, and now there is also research center in the Department of Mathematics. So it's a full-fledged center for learning mathematics right from 11th standard to PhD if one wants to do that. And emphasis has been always on quality and conceptual training. We have got a decent, very nice, huge library within department and also in the main library. And we have enthusiastic, very qualified teachers, and department has several distinguishing features like mathematics exhibition, which is very rarely done in mathematics departments, but we have been doing it for last 50 years, and people across the state and almost all schools in Pune city have already visited this exhibition. I'm very happy and proud to say that our today's guest and speaker Abhijit Ranzekar had made substantial contribution in developing this maths exhibition in Department of Mathematics. When he was a student, the exhibition came out of a small room to a big hall, and lots of new exhibits were produced by him. So he has been a very enthusiastic, very intelligent, very bright student from day one. And this exhibition gave me chance to talk about him a few words. Recently means 10 years back, we started a very novel activity called Madhava Mathematics Competition. That's a mathematics competition for undergraduate students. And because I happened to be associated with Maths Olympiad for many years, I thought that this competition can be extended to undergraduates. And in 2009-10, I suppose, we started this competition for undergraduates, and initially 800 students participate, and now about 10,000 students last year registered for this, and competition took place in 23 regions across the country, and it has a full-fledged blossomed into a national level competition for undergraduates in India, and government of India has taken complete responsibility of funding this competition. So we are proud that we could contribute at a national level. So there are various activities going on in the department. We are selected as DBT Star College department from the Department of Biotechnology, and we are running some activities on in under that funding. And currently, our colleague Gitanjali has completed her PhD in mathematics. Other colleagues are pursuing their research. So, apart from teaching, teachers are also doing whatever research they can do within the given framework. So, I am very happy and proud to be member of this mathematics department. And I think I can go on and on if I wish to talk on the department, because I have been working here for 35 years. So, but I know that today I am not the speaker, and we have another speaker who is also from the department in a way. So I stop here, and thanks for giving me a chance to talk briefly on the mathematics department. Thank you.
Thank you, sir, for your brief introduction and also the always active support to the different activities of Science Association. Now, I would like to ask Dr. Gitanjali Pathak, please give the introduction of today's eminent speaker, Dr. Abhijit Ranjekar.
Thank you, Kakade sir. Actually, Dr. Abhijit is not guest for our department. He is very meritorious past student of our department. He has completed BSc from Department of Mathematics, SP College. Then he has completed MSc from Pune University and also PhD in operator theory from Pune University. Currently, he is working as practice head in Wipro. He is very much interested in the subject, and I am sure that you all will enjoy his lecture. Thank you.
Thank you, madam. Now, I would like to request Dr. Abhijit Ranjekar, please start your session. Please, sir.
Thanks a lot, Kakre sir. Thanks a lot, Solapurkar sir. It's a pleasure and a privilege to be associated with SP College, and I really thank the Science Association for inviting me here. It will be almost 30 years of my association with this college, so I'm really proud to be alumni of this. Let's go to our lecture today. Sir, let me know if you can see only the slide in
Yes.
the slide mode now.
It is visible, sir.
Okay. What we are going to do today is we are going to look at mathematics in the nature. And because this is a mathematics lecture, I would want you to do some mathematics actively as well. But of course, I won't make you tired. So let's get started. So typically, mathematics starts as numbers, and right from the childhood, we start with counting. So 1, 2, 3, and then comes the 0. So essentially, the first introduction or the first entity that comes in mathematics is the natural numbers. And then when you add 0, you have got the set of what is called as the whole numbers. Then comes the direction. So if you then learn -1, -2, which is essentially forming the set of integers. So you have got the positive direction, negative direction, and then you extend your numbers to what are called as integers. Then comes what are called as fractions. So you divide the entire quantity in some parts, 1/4, 1/8, half, and that is where you get introduced to fractions. And right from your childhood, you see fractions all around you. In mathematical terms, the fractions are called as rational numbers. So a rational number is typically represented as P upon Q, where P and Q are integers. After that, you encounter a strange set of numbers, pi, √2, some decimals that just don't stop. And then you are told that these numbers are to be called as irrational numbers. While you kind of accept them, but you are always wondering what those irrational numbers are. and it starts with a very simple right angle triangle, both sides having 1, and the diagonal, which is the very simplest form of the side of that triangle, is √2, and then you are told that √2 is an irrational number, and then √3, √5, all of them are irrational numbers. So you often wonder what these irrational numbers are, and they seem to be very artificial. And by the way, if you start counting all the numbers, the irrational numbers are actually far more than the natural numbers plus the fractions together. So those of you who have learned mathematics in detail, you would know that the irrational numbers are far more than fractions and natural numbers. So now let's try to understand how this mathematics gets into the nature, and whether these irrational numbers are really very artificial. So going from the black and white topic of mathematics, let us get into some colorful world of plants. What we are going to look at is the growth of leaves on the plant. So what you are seeing here is 3 different plants, and the growing part, the apex of each of these plants. What we are going to look is how the leaves are growing on this plant. So if you look at this first plant, you would see this leaf. I mean, the other leaves are below, but we'll start looking from here. So this leaf is coming up here. Then the next leaf is here. You can see in the photo, it is at the back end. And then the next leaf is here. The further leaf, it has grown here. Then the next leaf is going to be growing here, and so on and so forth. This part is yet to fully grow, but you can see those leaves coming up here. Okay, now let us look at this plant. So as you can see here, the first leaf here, then here, the third one is here, fourth one is here. And as you go towards the bud, you will have those leaves placed very near to each other. But essentially, this is how they are growing. Now let us look at this third plant. Here again, you will see the leaves kind of going all around. And then at the apex, you will see all of them crowded together. And then essentially, this is going to keep growing. So this is how you would agree that the growth of leaves happens. Some biological terms. So the part where a leaf grows or originates is called as node. And so this is a node, this is a node, every place where a leaf originates. And then you see a part of the stem between 2 nodes, that is called as an internode. So the plant growth can be picturized in this manner. So there is a node, a leaf comes up. Then there is a growth of internode, which is the part of stem, in such a way that the stem turns by some angle, the stem rises up slightly, and a new node or a leaf comes up. Okay, you have got a node where a leaf comes up, then the stem slightly increases in height, it turns by some angle, and a new leaf comes up. And this cycle continues. So let us quickly go back to the previous slide. Now, do you realize node, stem grows up, there's a slight turn, new leaf. Again, stem grows, slight turn, new leaf, as you can see all over here, right? So what is effectively happening is the stem is growing, turning a little bit, and a new node or a leaf comes up. That is how the growth of leaves happen. Now, what we are going to study is in the biological terms, it is called as phyllotaxy. Phyllotaxy is essentially the study of arrangement of leaves on a stem. So we have seen that the leaves originate or grow on the stem in a particular pattern. And the spacing or placement or the divergence between successive leaves or nodes is what is called as phyllotaxy. Okay. Phyllotaxy also is about study of how many leaves shoot up or originate at the same time, and how do the consecutive leaves distance themselves. So this is essentially phyllotaxy, and naturally this is going to involve mathematics. So now let us try to understand, when you are talking about a plant, what is the key objective or what is the key purpose of a plant having leaves, and then why should there be some purpose in the arrangement or placement of those leaves. So naturally, all of you know, you have been learning from your childhood that leaves produce food for the plant. So phyllotaxy, photosynthesis is what all of you have learned. So leaves essentially produce food, and all of you know that the food preparation happens only when there is exposure to sunlight. So for all the leaves to be able to prepare the food, all of them should get enough sunlight. So there should be exposure to sunlight for all the leaves, and all of them should get good sunlight. The other key function of the leaves or the arrangement of leaves determines is channeling all the rainwater towards the roots. So if you have seen trees with big enough leaves, and in the rainy time, you would see that all the leaves are kind of channeling the water downwards towards the roots. So the main function of leaf is food preparation, and that requires sunlight, and the leaves should be arranged in such a way that all of them should get fair amount of sunlight. All of you agree with this? Okay, let's move on. So now let us try to see what are some of the growth patterns. Now remember, we learned how the stem or the initial growth happens. You have got a node where a leaf comes up, then the stem rises up, turns slightly, and you get another leaf. So what is this turn? So the simplest way is for the stem to turn by 180 degrees. So one leaf comes up, the stem turns by 180 degrees, and another leaf comes up. Again, it slightly grows up, turns by 180 degrees, another leaf. 180 degrees, another leaf, and so on and so forth. So simplest way is turn by 180 degrees. So if you see from above, this is what you will see. Now let us look at some simple examples. So as you can see here, a leaf has come up, turn by 180 degrees, another leaf, 180, another leaf, so on and so forth. You can clearly see that happening here. This is another example. This is the Harbara tree. One leaf, the stem has turned by 180 degrees, another leaf, so on and so forth. As you can see, the same pattern continues. So effectively, the stem is turning by half. So here the stem is taking a half turn, a new leaf comes up. Half turn, new leaf comes up. Half turn, new leaf comes up. Right? Now let us look at some more examples. So this is Sontakka tree. You can see a leaf here, half a turn, another leaf, half a turn, next leaf, half a turn, and this pattern continues. This is the Avla tree, or the Rai Avla or Dongri Avla. Then you can see every leaf half a turn, and then the growth continues. This is the Sitapal tree. You can clearly see first leaf, half turn, second leaf, half turn, next leaf, so on and so forth. So effectively, where what you see here is in all these growth patterns, the stem is turning by half, and of course growing further, and then the new leaf coming up. Let's look at some more. Now this is typically called as Ajwain or Oa. You can see here at a time clearly two leaves are coming up, not a single leaf as we have seen earlier. So two leaves coming up, then there is a turn, another set of 2 leaves, then there is a turn, another set of 2 leaves, right? This is again mint or pudina. Here again, you can see at a time 2 leaves are coming up, then it is taking a turn, next pair comes up, taking a turn, next pair, and this pattern continues. Now here, if you have thought or calculated in your mind, here it is turning by 1/4, because there are 2 leaves by 90 degrees or 1/4, the turn is happening, and then you have got another pair of leaves, right? This is golden duranta, which is typically used on the compounds, but this is given all different shapes, so you may not realize. But here again, you can see 2 pairs coming up and a turn by 1/4. Some more example. This is a plant called Ananta. Two different varieties. Again, you have got 2 leaves coming up at a time, 1/4 turn, and it continues. This is a cactus. Clearly, you can see 2 leaves and taking a turn, right? So we have seen examples where plants are growing by taking half a turn. Here, plants are growing by taking turn of 1/4. Now, I'm sure everyone is muted, but how many leaves are growing at a single time here? You would realize that a triplet or 3 leaves are growing at a single time. Then it is taking a turn. Now, how much is this turn? It is taking kind of a 1/3 turn. And then next triplet of leaves is coming up. And then it is taking 1/3 turn. So if you see it from above, it will look something like this, right? This is another example. This is a creeper. So here you are seeing that 3 leaves are coming up and the turn taken is 1/3. So now we saw what is the objective of leaves. They are going to prepare food, so all of them should get good exposure to sunlight. Now let us look at different growth patterns and understand how they can get equal sunlight. So here we looked at the examples where there is a turn by 1/2. So the first and the second leaf are fine. Third leaf has no choice but to get over the first one. The next leaf gets over the second one. So every alternate leaf is kind of on top of one another, right? Now let us look at this turn by 1/3. Again here, the first layer, the second layer would not have any overlap, but the third layer, once this inner set of leaves grow, they will directly overlap on the first leaf, right? So when you take a turn by half, the third leaf overlaps with the first leaf. When you take a turn by 1/3, again the fourth leaf overlaps with the first leaf, right? Now let us look at these overlaps. So again, Pudina, as the leaves grow more, you can see that these two are going to cover the leaves that are below. This is Tulsi. You can clearly see that these two are covering the leaves underneath. These two ones are covering the leaves that are below. This is Kanir. Turn by 1/3, 3 leaves coming up. So again, you can see only the initial are new, otherwise everyone else is going to cover everyone else. So when you are turning by half, or when you are turning by 1/4, or when you are turning by 1/3, either the third or the fourth or the second leaf is going to overlap on the previous leaves, right? So we have looked at turn by half, 1/3. So if you are going to take a turn by 1/n, then naturally first, second, third, and nth leaves will be fine. But the n+1th leaf has no option but to get over the first. So what is the best possible arrangement to avoid the overlap? Now let us say if we take a turn by m/n. So let us take an example of turning by 2/3. So this is the first leaf. The stem turns by 2/3. Second leaf comes here. Now the stem takes a turn by 2/3 again. Third leaf comes here. Now the stem turns by 2/3 again. The fourth leaf comes here. Now again, as you can see, first, second, third leaves are okay, but the fourth leaf overlaps with the second leaf. So in general, if the stem takes a turn by P upon Q, the first, second, third, dot, 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 till Q, the leaves will be fine. But after you finish the Q leaves, the Q plus 1th leaf that comes up will have no choice but to overlap with some of the previous leaves. All of you agree with this, right? Okay. Now, if we want to have the turning in such a way that there is no complete overlap on the previously grown leaf, then the turn cannot be a fraction, because we have seen if we take it P by Q, then Q plus 1th leaf is going to overlap with the previous leaves. So this turn cannot be P by Q. It cannot be a simple decimal. I mean, if we take 0.2 or 0.3, effectively you can express them as 2 by 10 or 3 by 10, which is again in the form of P by Q. So even if you have a simple decimal, it can be expressed in P upon Q, and again Q plus 1th leaf will overlap. So what is the only choice left for the stem? So the only choice left is the turn has to be an irrational number. So irrational means it cannot be expressed in the form P upon Q. And if you remember your school definition, it is non-recurring, non-terminating decimal. So nature has naturally created these irrational numbers so that there is growth happening in such a way that there is no complete overlap. So while howsoever artificial you may find them, nature itself has created these irrational numbers. Now the question is, do we really have or see such arrangements where there is a turn happening in such a way that the overlap is minimum, there is no complete overlap? Let us look at some examples. So this is the Tamalpatra leaf or Tamalpatra plant. So here you can clearly see that they are turning in a different angles, and if you see from top, there is no complete overlap of the leaves happening on one another. This is a very simple plant, Terda, and again you can see first leaf here, second, so there is a turn happening, and when you take the view from top, you can clearly see that there is no complete overlap. So these plants have understood turning by irrational number. Again, this is bougainville, very common. Again, you will see that they are turning at different angles, and if you take a top view, you will see that there is no complete overlap. This is a very good example, sunflower. Again, you can see the top view. There is no complete overlap. This is another beautiful plant that I found, and you can see this going like a nice staircase, and when you see from the top, you will see that the leaves are trying to avoid complete overlap as best as possible, and then the turn that is being made is really beautiful. And many more examples. So this is show plant, as you can see here. Then this is a cactus. This is Sadafuli, mango. So if you look at every new initial branch of mango, you will find that they don't overlap completely on each other. Now, while we are looking at leaves, you will find a similar arrangement in flowers as well as seeds. So you can see here they are growing in such a way that there is no overlap that is happening. rose petals, beautiful arrangement. This is pineapple or ananas, again very beautiful arrangement. So these are the same patterns that are followed for petals or seeds to be placed. So this is the seeds of a sunflower plant. This is the simple tantani or what you find on the roadside. This is mohat's zhad. So nature has them very beautifully created, and the pattern baked inside. So the next question is, what we have seen that there is this irrational number by which a plant takes a turn. So what is this irrational number that the nature uses? This number is called as the golden ratio, or in the Greek symbol, it is represented by phi. The value is 1.618, and of course you know that this decimal cannot stop because it is an irrational number. So what is the definition of this phi? So mathematically, the definition of phi is, if you have got any line segment, this point which divides the line segment in ratio A upon B, this point has to be placed in such a way that the ratio of the total length A plus B upon A is equal to A upon B. This is by definition phi, but the simpler definition are, it is solution of the quadratic equation x square minus x minus 1 equal to 0, or its expression is 1 plus root phi by 2, and then comes this familiar irrational number root phi. And because this is a solution to x square minus x equal to 1, that means x square is equal to, if you take both of them on the right hand side, 1 plus x, or phi is a number that satisfies phi square is equal to 1 plus phi. Now this is very beautiful. This phi number is such a number that its square is simply the same number plus 1. Something very difficult to imagine, that the square of that number is simply that number plus 1. That's the beauty of phi. Let us look at some other geometries where phi can be seen. If you take 3 equal lines, place the first line vertical. At its midpoint, place the second line. At its midpoint, place the third line. Now this ratio ABS to BG is again phi. Another one is, you take a circle, draw an equilateral triangle inside the circle, then draw a line through midpoints of this equilateral triangle. Then AB upon BG is again phi. Another example is, take a circle, on that diameter construct a square at the top, then again AB upon BG is phi. You take a circle, draw a pentagon inside, and then AB upon BG is phi. So with a circle and triangle, square, pentagon, you naturally see this phi occurring. Now let us look at some more algebraic expressions where phi occurs. Now again, this is written in such a way that this is square root of 1 plus root 1 plus root 1 plus root 1. So this root continues. Okay, so let's find out what this number will be. It is root of 1 plus root 1 plus root 1 plus, and so on and so forth. It continues. So let's find out what this is. So let us call this x. Now, because it is a root, if you want to find that out, we will take its square. When you square this, what will be x square? If x is this, and when you are squaring this, the first root sign will go. Okay, so this root sign goes, then it is 1 plus what remains? Again, all of this. Now, if you look at what remains, what is this? This is simply the original number that we had, which is x. All of this is simply the original number x. So effectively x square is 1 plus x. That means, what is this number? This number is the defining number of phi, because phi, we saw that by definition phi is phi square equal to 1 plus phi. And therefore, this number, which looks very complicated, root of 1 plus, and that root continues, is phi. So such expressions where you have got root of root of root of root of root go and so on and so forth, they are called as continued roots or nested radical. Now this simple looking number, it has got only 111, but all the roots again naturally gives you number phi. Let's look at some more algebraic expressions. Okay, now this time instead of taking a square root, I am going on taking divisions. Okay, 1 plus 1 upon 1 plus 1 upon 1 plus. So I'm just going on and on and on. Okay, now let us call this x. Let us try to find out what this number is. Now if you call this x, and if I hide these two, what do you find? What is this remaining? That is again x. Right? So effectively, what you have, 1 plus 1 upon x is equal to x. And then you can simply do a multiplication. That means x plus 1 is equal to x square. Again, you get the defining equation for phi. Phi square is equal to 1 plus phi. So again, this innocent looking expression, 1 plus 1 plus 1 upon 1, is again that golden ratio. Now such expressions are called as continued fractions. So you are continuing, going on taking the fractions continuously. Earlier it was you are going on taking the roots, so it was radical. Now this is called as continued fraction. Now again you will see that I am writing something for the sake of mathematics, 1 plus 1 upon 1 plus 1 upon 1 plus. So are they again something artificial? So can a normal number or a fraction be expressed as a continued fraction? So now that we are in a mathematics lecture, let's try to learn a little bit of mathematics. Okay, so now let us see if we can do something with these continued fractions. So let us try number 50 upon 13. Let us try to express it in a continued fraction way. The way we are going to do this, it is called as what is called as squaring the rectangle. So what I'm going to do, because I want to convert this number 50 upon 13, I'm going to take a rectangle whose one side is 50 and other side is 13. Now going by the title, I have to do squaring of this rectangle. That means I have to make as much squares in this as possible. So if I have to make squares in this, all of you would agree that I would have to start with making adding a square which is 13 by 13. So let's try to cover this rectangle with 13 by 13 squares. So naturally, how many will fit inside? 1, 2, and 3. So 13 3s are 39. Can you fit another 13 by 13 square? No, you cannot, because the remaining is now 11, right? So what remains is 11 by 13. So what you are going to see, 15 upon 13, that is what we wanted to start with, is 13 plus 13 plus 13 plus 11, 13 plus 13 plus 13 plus 11 upon 13. I'm just breaking this 50. Now simplifying this, so it is all these 13 3s plus 11 by 13. Now this 11 by 13, I'm going to do a little bit of trick, and I'm going to rearrange it as 1 upon 13 by 11. Okay, 11 upon 13, I'm arranging it as 1 upon 13 upon 11. Now this 13 upon 11 is a part that is yet to be covered with squares. I want to cover it with squares. So what is the most natural candidate that comes to your mind? This is 11. So the maximum that I can fit is a 11 by 11 square. And obviously there is no more room, and what is remaining is 2, right? So this 13 upon 11, I'm going to write as 11 plus 2 upon 11. So that is 3 plus 1 plus 1 upon 2 plus 11. So this simply breaks as 2 plus 11. Now this part is yet to be covered with squares. Now how do you go about it? Again, this 2 by 11, I'm going to write as 1 upon 1 plus 11 by 2. Now I want to cover these squares. So naturally I will draw 2 by 2 squares. How many I can draw? 1, 2, 3, 4, 5. And what will remain? 1, right? So this I will start continuing to break up. So this 11 by 2, I'll write 2, 2, 2, 2, 2, 5 times, and that becomes 5 plus 1 by 2. So now you can see these continued fractions coming up here, and this 1 remaining here, and then naturally you can cover it with a 1 by 1 square. So now this rectangle we have completely covered with squares, and what that has got us is a continued fraction. So there's a short way of representing this continued fraction. You have to start with the first number 3, and then you have to just write 1, 5, 2, which are the continuous coefficients, and then you know how to write 1 upon 1, 1 upon 1, 1 upon 1. Okay, good. So now a normal number, you can express it in the form of a continued fraction. Let's look at another example. Okay, so this is the summary. So this 13 by 50, we have been able to write it as 3 plus 1 upon 1 plus 1 upon 5 plus 1 upon 2. So this 3, 1, 5, 2 is a representation, and we have been able to completely square this rectangle, right? This is a nice game. You can play this game with your kids, and they will enjoy it. So when we square this rectangle, we get 3 yellow squares, 13 by 13, 1 green square, 11 by 11, 5 brown square, 2 by 2, and 2 yellow squares, 1 by 1. Now all of you have learned greatest common divisor, GCD or HCF, and in the school you have learned how do you do GCD of two numbers. You would do the division of 50 by 13, and then you get 3 into 13 plus 11. Then you would do 11 and 13 division, which is 1 into 11 plus 2. Then you would do 11 and 2 division, and then you would get the division of 1 and 2. And this is what corresponds to these squares that we have seen geometrically. So effectively, when you are finding GCD of two numbers, this nice geometrical activity is what you are doing. And then you have learned that whatever is the last divisor is the GCD. This is what you have learned in the school. So effectively, these last two yellow squares, whatever are the last squares, that becomes the GCD of those two numbers, right? So this connects geometry, this connects GCD, and this connects the way you have been doing it in the school. Let's do it one more time for some other number. Okay, let us look at some fat numbers, 36 and 88. Okay, those of you who have understood the method, you can start doing it. So naturally you will start with taking this rectangle 36 by 88. Now what is the first square that comes to your mind? It has to be 36 by 36. Naturally you will see two squares fitting in there. What remains is 16. So 88 by 36 is 36 plus 16 upon 36. So it is 2 plus 16 by 36. Now what I'm going to do with this 16 by 36, I'm going to write it as 1 upon 36 by 16, and I'm going to complete the squares here. So you will have naturally 16 by 16. How many squares will be there? 2 squares, and what will remain is 4. So let us do this fraction here. So 16 by 36 is 16 plus 16 plus 4 by 16, which is 2 plus 4 by 16. Again, I'm going to do 4 by 16, 1 upon 16 by 4. Now this is the remaining part that I have to cover. Now I'm naturally going to go with 4 by 4 squares. Okay, 1, 2, 3, 4, and all of them got covered, right? And the representation here is 2 plus 1, 1 upon 2 plus 1 by 4. So this is the representation. And now if you go in your way of finding GCD, again, this second last number 4 is the GCD, and this was precisely the last square that we could fit in. Okay, and by this we are relating three different entities. One, a continued fraction representation. Two, the geometrical tiling. And three, the GCD. Right? So the continued fractions that we have seen again are not artificial. They look to be very interesting. And the beautiful part is that if you go back to 1 plus 1 plus 1, it goes on flowing, and that is the advantage of having a continued fraction. Now you know the trees have to keep on growing. So if you have seen any of these fractions, here the continued fraction stops, right? And for a plant, the growth cannot stop, and that is where the phi that we have seen, the representation 1 plus 1 plus 1 plus 1, it keeps on growing. So that facilitates the growth of a plant, and it is naturally related to a normal fractions. And you know that the fraction, any decimal can be, or any rational number can be expressed as a continued fraction which stops at some point of time, right? So these continued fractions are again something very interesting, and they are not artificial. You can express every fraction as a continued fraction, and they come up naturally when you want to cover the rectangle with squares. So they come up in squaring that rectangle. They are also related to GCD and HCF. And obviously by now you would have understood that every fraction has a finite continued fraction representation. So a number is rational only if it is a simple finite continued, and when it becomes irrational, its continued fraction doesn't stop anywhere. So irrational numbers have infinite continued fraction. Very good. So going back to where we started with the golden number, its representation as a continued fraction. And where does this phi occur? Phi occurs when we are studying the growth of the leaves, or even arrangement of petals, and then ultimately the growth patterns of a plant. Okay, so now you can see different plants. Now it has to because it is growing by taking half a turn, it cannot do a lot of branching. So that is where it has got this kind of a growth pattern. Same is the case with Avada plant. Okay, you can see that the growth pattern is not uniform, whereas when you see a mango tree, you can see that all of them are able to get very nice sunlight. So the way phyllotaxy, or the growth happens on the leaves, it also determines the growth pattern of the plant. So this is mint. As you can see here, there is going to be overlap. So it will do a lot of branching. So you would see a thick bush. This is Kaner, again overlaps. So you would see growing it in a thick bush. Good. So now we come to the last part of our lecture. So what we started with was numbers, natural numbers, integers, fractions, and then the irrational numbers is what comes to your mind, and you find that they are quite artificial. And then what we have seen is the growth of leaves on a plant is associated with some mathematics, and that involves turning of a stem by some fraction. And if you want to have equal sunlight or minimum overlap, then the stem has to turn by an irrational number. And that gives you a different perspective of looking at the trees again. Find out how the leaves are arranged. Look at the plants from a different perspective. Find their phyllotaxy. Now, looking at the phyllotaxy, try to see what will be the growth pattern. You can take those photos, share with me, and given that these irrational numbers are coming up naturally, you can start loving those irrational numbers. I mean, I know you wouldn't have like √2, √5, pi, and so on and so forth, but now you know this golden number 5 seems to be very lovable and interesting. So start looking at it. We also learned continued fractions and doing squaring of the rectangle and how it is related to finding the GCD. So you can play around these games with your kids and share your experience. So with this, I would like to thank you all, and we'll open up the session for any questions that you would have. Thanks a lot, everyone. Sir, if there are any questions.
Hello.
Yes.
Sir, I have some questions from students.
Yes.
First one is nowadays students are asked nowadays what are the main application and where golden ratio use? Since you are already mentioned the golden number, so students are interesting about the golden ratio.
Yeah, so when you do a Google search on golden ratio, you will find a lot of interesting articles. One of the illustrations is the spiral that you see, the growth of sunflower seeds. And then you would see them in the art that if you draw a picture of a river and you want to have the ship being drawn, then if you draw it at a point where phi ratio comes up, that is 1.6, then it gives a different depth. And then you would see pictures of Mona Lisa, and then the Greek Roman architectures. So you will find phi at many places. But this particular example I took because you wouldn't find that on the internet. That's where my objective was to give you a different perspective or a different application where you actually see phi. So you can see phi golden number or golden ratio in arts, in drawings, in architecture, and now here in plants as well. Okay.
Okay, sir. Or hello, sir. Second question is that students are asking that nowadays or in our regular study courses, if you study the mathematical courses, students always ask that what are the main application of mathematics. So can colleges or university starting this type of courses like mathematics in nature, or all students are comfortable with this, or more interesting about mathematics and all these things?
Sure. So I think I will answer this in two parts. Part number one, college courses. So while I can definitely comment about SP College, which is organizing this, they do have multiple courses and that have got a lot of applied mathematics. So in terms of your curriculum, there can be courses, and university is definitely making attempts to add application based courses, and you would see some applications, and given the advance of mobiles, FY and SY, first year and second year science, there are going to be some courses on which you will actually do practicals based on mathematics in some mobile apps. That is number one. And number two, not only in academics, but you would have heard a lot about data science, machine learning. Trust me, all of it is entirely mathematics. So you would have college courses up to all the latest technologies based on mathematics. So don't worry, mathematics is at the core of everything.
Okay, thank you, sir.
Thank.
Okay, so if there are no more questions, I can hand it back to Kakade sir. And as I said, I want all of you to do these things next. Look at the plants, look at their patterns, and share those photos with me when you find interesting phyllotaxis. Okay. Thanks a lot. Over to you, Kakade sir.
Thank you, sir. Very nice session and very enthusiastic session. Amar sir, may I have any question?
No, sir. No, sir.
Okay.
Complete.
Okay, fine. So we'll have to go for the valedictory function of the science talks organized by Science Association. So now I would like to give brief review of this particular science talks organized by Science Association. So we are waiting since principal ma'am, Professor Savita Datar, will join very soon. So we'll wait for a few minutes and we'll start the valedictory function. So meanwhile, sir, your talk is very enthusiastic. We understood that which are the rational numbers or irrational numbers, and how in simplified manner we can see that application in a nature. So everything is very good at all sides. Means, since we thought that mathematics is a subject in which we are doing the calculations and all, but we never thought that the subject is also plays a significant role in the nature, and we can see the different its application as the natural one as you have shown it. So we'll wait for a few minutes since ma'am is coming.
So from general audience, if there are any questions, I can take it.
Yeah. Professor, you can continue. You can have a also have Gitanjali Pathak ma'am. Please, ma'am, you have any question? We also have. Let's take one. Okay, so just a few seconds we'll start the session. So now I would like to request you, please speak the few words regarding the series of Science Association and the overall experience of you with the Science Association. Please, sir. I would like to request the Abhijit Danjekar, sir. Please share your experience.
Yeah, so it is very glad to see Science Association taking this shape and form. As mentioned by Solapurkar sir, maybe around 24 years back, we started with having exhibitions for mathematics, and we did move, as sir mentioned, the mathematics exhibition from a small room to a big hall. With all the different mechanisms or different models, and kind of made it as good as physics and chemistry, and even the Science Association at that point of time used to do all these exhibitions. I think typically they used to happen around the Science Day, I think end of February, right? Now with this COVID situation, it gives an opportunity for the Science Association to have them in a virtual manner, so that the participation can be at a large scale. So typically earlier it used to happen only in the colleges, and the college students would come and watch the lectures or hear the lectures and watch those exhibitions. But with COVID giving these virtual channels, I think it is very good to have this exposure to a large public crowd. So thanks a lot. I think you can make this broadcast more and more better as you go into the next years, and have this in a virtual manner itself, even if the colleges start, so that you would have a lot more participation, and the science would reach to a very large audience. So thanks a lot, Kakade sir, and it's a very good work being done by the Science Association. So I would like to have them a big round of applause. Thanks a lot from everyone. Sir, I could see this strip rolling which says an essay.
Sir, just a few minutes, sir. We'll come back.
So this, essay competition was held. So any update on the essay competition, or the evaluations are ongoing?
Actually, we have organized the essay competition for the student of junior college, senior college, and all postgraduate students. So that submission is ongoing here, and we have received a huge response from the student side also.
That is very encouraging to hear. So I think
yes,
we'll have a lot of work.
According to the current NEP, we have proposed a lot of subjects in benefits of students. So they will they will take part in these different competitions, and they can win the prizes. We have total around 25,000 rupees cash prize we have proposed for this particular event. So you hopefully think that a lot of actually we also have received a huge response, and we are expecting that all students will take benefit from it.
Right. That's
for
very.
For a few minutes, since ma'am has not received a link, just she will join and then we'll continue the session. Only a few minutes. Sorry for delay.
Sure, no worries. I think in the meantime, Solapurkar sir mentioned about the Madhava competition. So that's another good one. So those who are interested in mathematics should definitely attempt this Madhava competition. And I think it is open from first year to third year, all the students. So it would be definitely interesting to participate. And if Gitanjali madam are there, then she can give a brief overview of that. And even Solapurkar sir is also associated with Bhaskaracharya Pratishthan, which is another great institute of mathematics in Pune. They also conduct the batches for mathematics Olympiad, be it Indian level or international level. And they are also having some sessions for school children, right from 8th. So that's where those interested can definitely take part in that as well. So a lot of venues for people who are enthusiastic and students who are willing to do mathematics.
I think ma'am is coming here. She's just joining the session. Due to some technical difficulty, we are waiting. Yeah, she's with us now. So, welcome, ma'am. On the desk of Science Association, today's enthusiastic talk was held in the subject of mathematics in nature. The eminent speaker is Dr. Abhijit Ranjekar from the practice head from Wipro. So now I would like to give brief review about the Science Talk series organized by Science Association. So in the COVID-19 pandemic situation, we thought that students are at home and think that it is better if we give some inputs to them, since as it is not possible to organize such kind of functions via offline mode. So we have organized this function via online mode, and all talks are live from the Facebook page. So this series started from the 15th of January, and today is the conclusion, that is the 23rd January. We have communicated this message to all students, and they took a benefit from this series. The different lectures held on the different subjects like physics, chemistry, mathematics, statistics, electronics, botany, zoology, geography, and computer science. So total 9 subjects are there in a science at our college. So we have organized the science talks in each subject in collaboration with the individual department, and we also have received a very good response from all the HODs as well as the different faculty members from our college. Almost 700 to 800 visitors are there. They are looking towards our talks, and the 300 to 400 are the active participations we have received for each talk. So in cumulative way, if I say, then total about 6,000 to 7,000 speakers took a benefit from this talk, and almost 4,000 are the active participations. They are involved in this particular 9 lecture series. So this is a very enthusiastic thing for us, and that inspired us that too many people, too many students and participants are taking benefit from such a talks. So we have to particularly this science talk series itself make a benchmark, since we have invited the speakers from the national, international, and the renowned institutes, including the Cambridge University, UK. So, and all the topics which we have received from the speakers, they are the heart-touching topics, and students are motivated from such kind of topics. So we are thankful to all speakers, those have delivered their talks in the particular science talk series, and also the speakers. We have a very good combination of young and experienced research persons. So that is also helpful, and so for that reason, I think this creates a benchmark for us, and for this fruitful success, I am thankful to all my colleagues. Now, we also have started this year the different activities from the desk of Science Association. We have started the state level essay competition for junior college, undergraduate students, and the postgraduate students. And total about 25,000 rupees prize, cash prizes will be there. So actually, this activity we have organized in collaboration with Indian Association of Physics Teachers, Pune Sub-Regional Council, and we also have organized the NGP preparation lecture series in collaboration with them. We also have conducted almost 10 lectures for the students' benefits, and we also have started this year in collaboration with the Vignan Bharati, the different talks from this different national and international renowned institutes. So that talk was held, and the director of Ayuka, we took the interview in the benefits of the students in the first talk, and that activity will go ahead in future also. We also have organized the astrophysics competition, particularly we can say science quiz for that particular students. So Science Association always works in the benefit of students, and we're expecting that a lot of students can take benefit from the desk of Science Association, and they can actively involve in the different activities of science association. So this is what the brief review about the science talks which we have conducted in this program. Thank you. So now I would like to request our principal, Dr. Savita Datar, to please say the few words about this series. Please, madam.
Good evening, everybody. Yes, it is really a very nice opportunity for the students that the Science Association team at SP College arranged this lecture series from all 9 departments of the science in the college. It has really become because of this interdisciplinary type of activity, and students must have. I'm sure that they must have enjoyed all the lectures. And this type of webinar or online lecture series was a new thing which occurred, or which we had to arrange this year because of Corona pandemic. Actually, Science Association is a very active activity at our college. The students at UG as well as PG level are given opportunity to work and in different areas with the help of under the guidance of teachers with different expertise. And we have different activities like PowerPoint presentation, lecture competitions, essay competitions, as well as science project exhibition competition. As I said for the last my department's lecture also, that we guide students not so much that it becomes our project, but the projects might be very less, but the enjoyment and the ideas come through the students. So this year, because of pandemic, everything was going on online, and we were thinking that what activities we will plan for the students through Science Association. And this we took it as an opportunity, and we could arrange lectures, diverse fields, and the students could get to hear these lectures through the stalwarts. So actually, I'm thinking that this lecture series, online lecture series, we should include every year in our Science Association activities. Because what happens with when we take science projects exhibition competition, we arrange it on one day. So all the departments are arranging science projects exhibition competitions, and the students from zoology, if he wants to go and see the projects in the another department, he gets very little time because he has made project in the zoology also. So this was the demand from our students. Many times I heard that you keep it for 2-3 days so that we can take part and go to our friends projects also, and which was not possible for us to arrange exhibition for 3 days. So I think Dr. Kakade sir, we should continue this type of interdisciplinary lecture series, online lecture series in Science Association activities every year, so that it will become an academic feast to all the students. And I'm really very proud that our Science Association team teachers, they contacted all the eminent scientists, stalwarts in various fields, and it must have been a great thing for our students. I also am very thankful to the great speakers who were with us throughout these days and shared their knowledge, shared their experiences and their talks with our youngsters. Our students are UG students mostly and PG departments. But because of this online series, as Dr. Kakade sir said, more than what I was expecting, more than that, the students have enjoyed and benefited through this lecture series. So, by concluding this series, I think students must be will keep on thinking and remembering different talks. Will come across, have already acquainted and came across with different scientists and speakers and stalwarts. And I'm sure that these young scientists from our college will contact all the speakers, will approach them, and that was what our aim was, that they should get inspired and they should get involved in the lecture series. So I'm very much proud and thankful to Science Association teachers from my college that they took this activity, and it turned out to be a wonderful thing. And also thankful to all the speakers who really spared their valuable time with us and delivered their talks. Thank you so much. Thank you so much.
Thank you, ma'am. Actually, it's inspired words for these all. My colleague of Science Association, those are actively working from last 9 days for the successful organization of Science Talk
Yes.
series.
Yes.
And I am very much thankful to the principal, Dr. Shet sir, then the former principal, Dr. Shet sir, former principal, Dr. Solapurkar sir, and now our new principal of our college, Dr. Sivita Datar madam also. Since all the principals actually that is our inspiration, they are believing us and inspiring us to arrange the different activities in the student benefits, and we are organizing that kind of things. As madam says that we have to continue this online series in next year also, so
Yes.
we'll definitely go for it, since we understood that the students took a lot of benefit from it. Actually, I am happy to say you that almost 10,000 are the likes to our Facebook page. Our Facebook page
Right.
is reached to
Right.
10,000 people, though we have started before the
Very
2 months actually. Since actually our few students, my students, those are working as a volunteers of Science Association. Jayesh and Vivek, actually, with the free of cost, not a 1 rupees investment, we have established our website of Science Association as well as the Facebook page of our Science Association. Where all different kind of activities, past activities, recent activities, upcoming events will be there. You can see, and student can take a benefit. So all things are very nicely arranged. So they understood that in which activity they can participate, and they can purposefully means take a help of the Science Association and can grow their particular idea. So I am very much thankful to all the principals, our vice principal, especially Professor Dhananjay Divte sir. They are also giving a big support to us. Then our all active member of Science Associations, all the HODs of the different science departments, and our all active participants encourage us. So I am thankful to everyone. Those are our inspiration, and due to which the series becomes successful. And once again, at last, again would like to thanks to Abhijit Anjekar sir, since spending a lot
Yes.
of time with us, and all the eminent speakers. So they also given a very enthusiastic talk. All talks are appreciated by all faculty members, different students, and we have received very positive response. So thanks once again to all of
Thank
you.
you.
Thank you, madam. And here I would
Thank
like to say that the Science Talk series is concluded here, and I would like to conclude the session also.
Thank you. Thank you, sir.